Welcome back to Seasons. Let's do a little more. Picking up where you left off, let's just review where we were. The tilt of 23.5 degrees, an important number you want to memorize, and the revolution around the sun are the primary reason we have seasons because it exposes different portions of that tilted part of the Earth to the more direct rays, the rays that hit at a higher angle and therefore hit more efficiently and hit for different amounts of time. The time thing is where I want to go with this video. So I think I'm going to skip that and that. We're going to go right to here. And it kind of goes along with the Sun's Path lab, which you should have finished up before you jump into these notes. So let's do it. In summer, we lean toward the sun. And the sun can take a higher path through the sky. So what the heck does that mean? Let's go over here to summer solstice. So this is June 21st, because we remember all of our dates over here already, right? We got those locked up upstairs. June 21st would be when we, here in the Northern Hemisphere, are leaning towards the sun. Therefore, as the planet leans into it, it will appear higher in the sky. So June 21st, in fact, is the day where it will have its highest altitude at solar noon. It will never go directly overhead here in Pulaski, outside of the Tropic of Cancer and the Tropic of Capricorn. That doesn't happen. But it will get pretty high in the sky on that day, and it's due to the lean. And now that lean also means that we're really exposed to the sun for a long period of time. Not today, but later we'll fill out these diagrams. Here's one for summer. North Pole is leaning into the sun. Therefore, if you take our latitude, which is right about here, we've got that much to spin through during the day when the sun is out, and then just this little bit to spin through at night because of that lean into the sun. So the sun's up for a long time. Oh, this will be the opposite. In winter, we lean away from the sun, and the sun takes a lower path through the sky. So all the opposite of the stuff I just said. Right up here, now it's leaning back, so the sun's hitting at a lower angle, and less of our latitude is exposed to the sunlight, meaning we've got a really long night. So let's again look down to this diagram that we'll do later on. And now we live right about there, still at the same latitude, but now since it's leaning back, only a little bit is out during the day. It's kind of depressing. This is right before Christmas, December 21st. This, by the time you get home from school, it's already dark. You wake up, it's dark. It's just dark, 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 right? So we get just that much, spin that much through the day, and then we got to spin all the way through all that and back around to the night. It's a very long night and a very short day. So that's what I would like to get into. For the summer solstice, this is our longest day. Good news, we don't have to memorize any actual numbers for times because that depends on your latitude. Winter solstice for us here in the Northern Hemisphere is our shortest day. What about these equinoxes? Well, once again, what's that root of that word equinox? What word is hiding in there? What goes on there? I feel like it's an awkward thing to try to explain. Lean towards, okay. Lean away, okay. What do you say here where you're not leaning towards or away? You're kind of leaning sideways is how we usually say it, right? What that ends up doing is exposing exactly half of the Earth at all latitudes to the sunny side and exactly half the Earth at all latitudes to the dark side. Let's do that on one of these diagrams. It's at this one, you might say, Mr. F, that one doesn't have any tilts, so it's wrong. And I see what you're saying. I like that you're thinking that, but what the tilt would actually be in this case is right out of the paper towards us or into the desk or your computer screen, whatever, right? So what's the deal with our latitude? Spin that much through the day and spin that much through the night. It looks pretty much like 50-50. And it is. That's what happens at the equinox. Wherever you live on Earth, because that's the day where this falls exactly perfectly like that, everybody's going to get 12-hour days and 12-hour nights. Now, there's some things that screw that up. But 12-hour day, 12-hour night. Any copying, Cammy? Oh, that's something we need later. Don't do that. There we go. 12-hour day, 12-hour nights. All right. Now, asterisk, I didn't put the H here. This is a tiny bit of a lie that we earth science teachers participate in. In reality, the atmosphere that we're quite fond of because it allows us to live bends light a little bit, and that's going to like suck the light around so that technically the sun, when you watch a sunset, technically straight line wise, the sun's already gone. But since the atmosphere bends that light towards us or refracts, we get a couple bonus minutes at sunrise, a couple bonus minutes at sunset. So the date of the equinox, this is not perfect, but A, the regents will pretend it is, and B, it kind of just makes it easy to all memorize. It's about right. It's off by a couple days. And the equinox is the season where we go from days that are longer than 12 hours to days that are shorter than 12 hours, or vice versa. If you're going from winter to summer, shorter to longer, it's got to pass by 12 and 12 at some point, and that is right around the time of the equinoxes. So it's that, but note that it's maybe just the smallest of fibs that we participate here in neuroscience. And you'll be great. So that's really all I want to do with this one. But it's another thing we got to get down. I'm not putting anything on this graph that isn't something that's got to be locked up in our noggin, and I'm doing it bit by bit on purpose. So let's go through it again, go through it again, go through it again. Equinoxes, solstices, 3, 6, 9, 12, all in the early 20s. Now we're adding in equinoxes have equal day and night, easy enough. Summer solstice are the longest day, winter solstice is the shortest day. That's going to get us to that thing that I accidentally pasted in here. Let's look at it. This is the next project you're going to do, where we're going to take the sunrise and sunset times throughout the whole entire year and make these little sheets out of it. It'll be much cooler looking in person, but it'll show us what the sunrise, what the day length looks like throughout the course of the year for Pulaski and for a couple other locations. We'll check it out. It'll be cool. Thanks for watching. Good luck on the next section.